Good morning, everyone. My name is Dave Medeiros. I am the president of the Chesapeake Region Safety Council. We are a regional independent chapter of the National Safety Council, and our mission is to educate and influence people to prevent accidental injury and death. In addition to being a chapter of the National Safety Council, we are also the lead partner with the Mid-Atlantic OSHA Training Institute Education Center, which means we are authorized by OSHA's Department of Training and Education to conduct the numbered OTI Ed Center courses such as OSHA 510, 511, etc. But today we're bringing you something really special. One of the other things I didn't want to miss is we are currently open and doing business. Okay, we are conducting training programs at various locations. Our primary location is in Woodlawn, Maryland, or right outside the Baltimore Beltway. But we also have virtual instructor-led training courses that we've been conducting on a regular basis. So if you check our website out at chesapeakesc.org or give us a call at 800-875-4770, we can help you out probably with some of the training that you might need to take, whether you want to come take it in person or take it through an online platform with the virtual instructor-led training. So I don't want to go too far into commercials because I want to tell you this guy, I've known him for probably 25 years. Okay, George Stallings. If there's a guy that knows his stuff about equipment, it's George. And I've had the opportunity, when you first meet somebody, they might not be an expert, but over the years that I've known George and his interaction and representation for different equipment lines, George has learned his stuff. George knows his stuff as far as personal protective equipment goes, fall protection gear goes, as far as confined space equipment goes, as far as visibility, high visibility equipment, traffic control. You know what? You name it, George knows his stuff. So sometimes people go, oh, he's an equipment rep. But you know what? With that equipment representation comes expertise. And I don't throw that term around loosely. I would refer to George as an expert on personal protective equipment. And I won't hold that Navy thing against him one bit. All right. So, all right, George. Hey, without further ado, it's all yours, buddy.
David, thank you very much for that introduction. It's outstanding, and I won't hold that Marine Corps thing against you, so I never have. Good morning to everybody at David and the Chesapeake Region Safety Council. Thank you for the opportunity to talk. And today's presentation is about personal protective equipment. And a lot of times people go right to PPE as a way and a means to protect their workers. And I kind of want to make sure that we use that as our last resort when we're talking about personal or protecting our workers, is making sure that we use PPE as a last resort, just like OSHA says. And so, because there are limitations to what personal protective equipment can do. And so what we're going to do today is go over the presentation and see if we can get this to work today. Okay. So the schedule is going to be we're going to go over our advancement and limitations of PPE. We're going to first speak about fall protection, then head protection, the changes in the marketplace, respiratory protection, especially with the KN95s coming into the marketplace, and we're dealing with COVID. A lot of people are grabbing any product they can to protect their workers. A lot of times I think we're going to run into issues with people's breathing. We'll get into that. And then hand protection, which is another area that is critical during the COVID situation. So we're going to focus on those four areas. Falls are a real big area that, last year in construction, we killed 338 workers, and 791 when we grabbed the industrial folks as well. So too many people are dying from falls. And the two areas I see a lot of problems with is the use of fall protection is leading edge retractables. People are using leading edge retractables, or regular retractables, I should say, in wrong situations, and where they should be using a leading edge retractable. And they're not reading the instructions and the limitations of the products that are out on the market. So first and foremost, let's talk about what a leading edge retractable is. The purpose of this segment of retractables was to develop a product that could be used at foot level and deal with the extreme forces of the cable impacting a leading edge. So that's critical. Regular cable 3/16 cable that we have in these small retractables or large retractables is not designed to take an impact against the sharp edge or leading edge, which is steel typically, or concrete. And so over the last couple of years, we've had 2 fatalities that I'm aware of people using retractables incorrectly, both the small web retractables and large cable retractables when their workers were around leading edges where they thought that the retractable would hold in that situation. And the real tragedy due to the loss of life beyond that is these workers thought that their fall protection that they were given was going to work. They wore it. And a lot of times we can't get people to wear safety equipment. These 2 individuals died wearing this equipment, thinking it was going to work properly. And what happened was, for whatever reason, they chose it, and I don't know why, but they chose incorrectly, and it cost them their life. And maybe it was their employer that chose it. But this is where today's presentation, every facet of PPE we're going to discuss, I want people to read the instructions. I want them to read the limitations of the equipment they're purchasing to protect their workers. I want you to focus lastly on PPE as a measure to protect your employees. So what happens in a leading edge situation? This is the testing that's done by ANSI, and it's the ANSI Z39.14 2014 standard. And basically, you take a 300, in the case of Fall Tech, we use a 310-pound weight. We drop it when it's elevated 6 feet in the air, and you can see in that graph that the retractable is going to be 5 feet below D-ring. And that's the minimum requirement for leading edge certification, is it has to be 5 feet below D-ring. It has to come across a sharp steel edge. That steel edge has to be sharpened to a 0.005 radius. And so what that means is every time it's tested, we have to sharpen that edge to make sure that that retractable sees the most severe sharpness that it can be exposed to survive the test. And so we have a lot of players out there who say leading edge, their product is leading edge, and a lot of employers out there who feel that cable can deal with any exposure, and it's simply not true. And so you want to make sure that you're dealing with a manufacturer that tests their products to the ANSI standard. And then they use means and methods to prove to you that they are doing so. And they have what we call a declaration of conformity. And if anybody needs to see these offline, let me know and I'll send you what they look like. And basically, it's a test documentation that shows you what the product dealt with, how it dealt with. It's typically 24 pages long. So you can see that the manufacturer has done the job of testing to the ANSI standard. And there's a visual picture of it. There are 2 options to testing. It's 282 is the minimum test method. And it's going over that sharp edge right there. It's a 10-second swing fall. It has to take afterwards. And they also have a 310-pound test, and we do a 310. The 300-pound test is 120 seconds post fall swing. And so we use both of those methods to test, and a manufacturer can use both those methods to test their leading edge equipment. It must be done in an ISO 17025 laboratory to be approved under ANSI Z39.14, and can't be done without a third party or that 17025 situation. You must have one of those 2 certifications from ISO or a PE to make sure that your product is passed. So it's pretty critical testing. So what's the difference? So it has to deal with a free fall. You have to be foot level, and foot level under ANSI is 5 feet below D-ring. And those are critical things that you want to make sure of that retractable can deal with. Again, we've had 2 fatalities, people using web retractables at their feet, exposed to a leading edge. And in one case, it was only designed for 2 feet below D-ring, and they used it at 5 feet below D-ring. And another situation where they had a cable retractable with 3/16 cable, not designed for leading edge, and both workers died from that result. So here are this is a few products that are out there that deal with leading edge. This is a 9-footer from Fall Tech. It can and is rated for 5 feet below D-ring. It has a maximum capacity when at 5 feet below D-ring of 310 pounds. It can do a 0 setback, which means I'm tied off at my feet right to the edge. You have to make sure that a retractable can do that. And it is 9 foot in length, and that allows for usage on scaffolds, so it gives you good reach. So that's one product. Here's another product from DBI Sala. It does have a 310-pound rating. They can go up to 420, but you have to make sure that when you go to 420, you're not using it in leading edge anymore. So if anybody's over 310, it must be anchored overhead. That's critical to look at those instructions. You just can't hand that retractable out to anybody and say, go ahead and use it, you're going to be safe. And if you look at their chart, they'll tell you exactly what the setback should be. The further you set back the anchor point from that edge, the better performance the retractable gets on both of the retractables I just showed. The worst situation is a zero setback. But watch your weights on those individuals. Once someone's over 310 with their equipment, it's no longer a leading edge unit for this retractable for this manufacturer. Here's one from Miller. This is theirs. They have a capacity. Same thing with them. They're going to tell you that after 310, you cannot use it for leading edge, and they tell you your setbacks. And if you look at their chart, the setback again is critical, just like it is for the other previous two. The further back you set that retractable, the better performance. What I mean by performance is the better it can deal with the free fall distance, and the lesser the free fall distance is, and that retractable reacts. And so they're pretty significant fall distances if you're rated zero edge. This one is a one from MSA. It has a capacity up to 310. It's interesting because they tell you can have a maximum below D-ring tie off at 3.9 feet. So technically this does not meet the leading edge standard, even though they're rating it for leading edge. This is where it comes into reading the instructions. The standard Z59.14 2014 states it must be 5 feet below standard, and this one allows you to only go to 3.9 feet. It also has a setback of 1.1 feet minimum, so you can't go at the zero edge like the other three retractables I pointed out there. So something to be aware of when you're using different manufacturers. They're not the same. The small personal retractables, and my personal belief in fall protection is that 6-foot shock absorbing lanyards are very dangerous and shouldn't be used in most situations. And so I try to sell people on the fact that retractables are better, and they are, but you have to, again, read instructions. And so these small retractables, the little 6-footers, are designed to replace lanyards. They're small and compact, and oftentimes they weigh less than the lanyard does. They have a quick reaction speeds. They can stop a fall 25 inches or less. In some cases, they're below 20 inches, depending on the performance. They're great for working in lifts, perfect for lifts, because in the lift, per the standard, the minute I get into a man lift, a scissor lift, I have to be tied off. I have to be tied off to the lift itself. And so a lanyard wouldn't prevent a person from hitting the ground in that situation. But please, like I say on the bottom here, read the instructions. Let's take a look at some instructions or what people are saying. This one's from Fall Tech, and it's a mini. It's a 6-foot long. It's Dyneema. And Dyneema is a cut-resistant material that we use in cut-resistant gloves. It is designed for lifts. It does have an anchorage of 5 feet below D-ring. It's not rated for leading edge, but it will deal with a fall if you're anchored at your feet, 5 feet below D-ring. It has a max arrest distance when anchored above at 25 inches. So it's super fast on stopping a fall. And it can go below your D-ring and can go at your feet. So some versatility in this retractable. This one next up is a DBI from Miller. It has a capacity of 420 pounds. Its max D-ring tie-off is 3 feet below D-ring. This one has, at that capacity, you have to be between 130 pounds and 310 pounds. If you're over that, you can have a maximum below D-ring at 2 feet. And so you have to watch your weight with your workers. Where are you tying that anchorage off to? If you're in a man lift or a bucket lift or scissor lift, a lot of times those D-ring anchor points for your fall protection is at a mid-rail or in the floor. So you have to watch where you're anchoring those retractables. So be careful when you go with those retractables in a lift to make sure that the manufacturer's recommendations, you're following them and the capacities. This is the Turbolite from Miller, very popular retractable. It has a capacity up to 400 pounds. It has no below D-ring tie-off allowed. It's overhead only. So if you're using a retractable like this one in a lift, you're not following the manufacturer's recommendations. And so it's critical that you follow these recommendations, because if a worker was tied off below D-ring with this retractable, there's a chance the retractable wouldn't work. And the manufacturer would clearly state that you did not use it in the means and method that we told you could. And that is a violation of the OSHA standards. They do mandate that you follow manufacturer's recommendations. So again, this is critical that you read that. This one's an interesting one from MSA. This is their mini personal fall limiter. It does have a 400-pound capacity. It is overhead only. They do have a graph here. It's hard to read it, but it shows you that this retractable is not bidirectional. And what I mean by that, the other three retractables I showed you can be used at the anchor point or it could be used on the back D-ring. This one is clearly stating that it only works when it's on your back D-ring. Do not use it at the anchor point level. So most retractables can operate in two directions. This one is telling you it cannot. And again, it's important that you follow manufacturer's recommendations in fall protection and as far as any PPE goes. So those are some of the limitations I wanted to talk about quickly when it comes to fall protection. Let's get into head protection. And there's a big change in head protection. You're seeing a lot of general contractors and subcontractors move into helmets. And the reason they're moving from hard hats to helmets is because the hard hat, like I have here, this technology was actually born 100 years ago, 1919, 101 years now. The last time we had a technological advancement was around 50 years ago. And the reason these folks are moving to new technology, moving from hard hats to helmets, is because of the amount of traumatic brain injury fatalities we have in construction. According to the CDC, during their study period, there was 2,200 fatalities in construction from traumatic brain injuries. And if you also follow CDC's recommendations or instructions, they tell you that 50% of all fall fatalities are traumatic brain injury related, which basically states that when somebody falls and dies, the coroner does a report and they look at what was the injury that caused the death. They don't say it was a fall. They say it was a traumatic brain injury or it was they were struck to the chest and some internal injuries caused it. So if we looked at last year, there was 338 fatalities from falls. If half of those were traumatic brain injury, we could have possibly prevented those by using a helmet instead of a hard hat. The interesting thing is that there's 120 fatalities from falls at same working surface. So that's interesting. That's slips, trips, and falls that we had people falling. And the important thing to recognize is the Z89 standard, which is the ANSI standard that controls head protection, which has been referenced by OSHA, is not a head protection standard. It's really a dropped object standard. And what I'm saying about that is was designed to protect your head from falling objects, not designed to protect your head when you fall. And so in construction or in the ANSI standard, we have two types of helmets. We have a type 1, like I have in my hand here. And a type 1 helmet is designed to protect your head against 2 square inches of impact on the top of the helmet. A type 2 helmet, which is primarily used in Canada, can deal with a lateral impact and a top impact only and has some foam inside it. Neither helmet is designed for fall protection. They're purely dropped object protection. So it's critical that we look at that. And so these large general contractors, and small, medium contractors, subcontractors are moving to helmets because they recognize that the standard is incomplete. There is a head protection standard in Europe that's called 12492 that will ask for head protection in the case of a fall, and we'll get to that in a second. But look at these shocking numbers. Last year alone, there was 235,000 injuries from falls. These folks have to deal with the injuries from the falls for the rest of their life. So there's 52,000 elevated surface injuries, 147,000 at same working surface. And when they fall, they slip, trip, and fall, that hard hat is coming off their head. And so we're asking that hard hat to do something it was never designed to do. We need head protection that will stay onto the body, onto the head, as the person falls, as they tumble, and not come off. And that's what the standard 12492 does. So what we're saying is we're going out and saying, look, get a helmet that's rated for Z89, and then also rate it for the European 12492 standard. And what 12492 standard is a true head protection standard. And that's a standard that will protect you from multiple impacts to the head, front, side, top of the helmet, and will stay on your head the entire time. So that's a critical part of this standard, is to making sure that when you fall or tumble, you're going to make multiple impacts to your head, that the helmet stays on your head. So that's what we're talking about on this standard, is to combine the two, the American standard with the European standard, to truly protect the worker. And here's a video of what happens in fall protection to helmets. So it's a side-by-side video of a person or a dummy falling One is going to have a helmet and one's going to have a hard hat. Interesting about this video as you watch it, a fall, even as pretty as this fall is, this is a straight vertical fall. It's still extremely violent. And you see the head jerk around, the body jerk around. This is not a swing fall situation like we most times see. And you see what happened to the hard hat? It fell off the head because there's no means or method to keep it on the head, and the helmet is staying clearly onto the dummy head. And so if there was a swing fall, the worker would have head protection. In the case of the dummy wearing the helmet, the person wearing the hard hat would not have head protection. And this is a video to show you the testing that we do. We put through the helmets, and this is a video that just gives you a comparison side by side of a helmet being impacted and a hard hat being impacted in a test lab. It does have a chin strap. The chin strap is important. And the chin strap is there to keep the helmet on your head at all times. So that's critical. And you see in that video, you saw the hard hat pop off the head. That's by design. The way the hard hat is designed to work is this gap between the suspension and the helmet itself, the hard shell, acts as a spring and falls off the head. So it's important to know that the helmet, while it falls off your head, is designed to do that, where the hard hat's designed to fall off your head. I'm sorry, the helmet is not. You see, that's a front impact. Now, remember, a Type 1 helmet is not designed for that, or a Type 1 hard hat is not, but a Type 1 helmet or 12492 helmet is. So the cast helmet on the left is designed to take that impact. The other helmet, hard hat on the other side, is not. And so the forces go screaming high, and the worker would be injured if they took a front impact on a standard hard hat. This is a frozen test. They freeze the helmets and the hard hats to get them below 20 to below 0. And so they can see how they survive an impact at super cold temperatures. And you can see that the impact value goes real high. So we know we're seeing some Type 2 impacts. Type 2 values, top and side, will go higher. Now, the cast helmets are designed to go well over any Type 2 impacts, whereas a standard Type 1 cannot deal with it. So these are just different tests that you're seeing. And you'll notice that each time the impact, the movement is different between the hard hat and the helmet. We want the helmet to stay intact on the head. We don't want it to move at all. Side impact, extremely violent. And you'll see what happens here with the hard hat. Because it has no means or method to stay onto the head, it falls off, and there is no protection now for the employee. Back impact. You watch the value on the next one, it goes sky high. That's typically because a Type 1 hard hat is not designed to protect the worker against a rear impact. There's no means or method inside a hard hat to do that, whereas helmets have foam to deal with that impact. Retention system staying on your head. That's how it stays on. And this is just checking the pressure to make sure that the hard hat or helmet doesn't dislodge. And so the bottom line is we're finally looking to put true head protection on the worker, much like we do with bike riding, motorcycle riding, skiing, equestrian, or any other type of method where we know someone's going to impact their head. We give them a helmet. Football, and there's tons of technology going into football to protect heads. And now finally technology is coming to the work site to protect the worker's head. It's interesting. We use something that costs roughly $10 in a hard hat to protect someone's head. We spend $300 to protect their feet. we should be the opposite. Our head is our CPU, it's our brain, it's our central processing unit, and we use the least amount of money to protect our head. This is an instruction from the manufacturers, just to basically show you. This is one of the manufacturer's instructions to say at the top right. It says, although it may provide head protection in event of a fall, this helmet is not designed for fall protection. That comes out of a Type 2 helmet, because I want to be clear with everyone. If it says Type 2 and it has foam, doesn't necessarily mean it's designed for fall protection. It certainly is not. It has to meet that 12492 standard to meet fall protection. A lot of other manufacturers are coming out with things that look like helmets, but please read the instructions. Again, this one here coming from 3M says, do not rely on a Type 1 helmet to provide front, side, or rear impact. So they have a product that looks like a helmet, but does not protect like a helmet. And so anything that's still Type 1 only, I would call a hard hat, even though it looks like a helmet. And so reading their instructions is critical. And this is the bottom line difference between the two. A hard hat was designed for just falling objects. It only has a 5-year shelf life, and it has a headband that the internal suspension, these nylon suspensions, must be changed annually. Whereas a helmet, you want to comply with both the Z89 standard and 12492. It's designed for fall protection and heavy impacts. It has a 10-year shelf life, and there's no need to replace anything during the whole life of the helmet. So there's a big difference between helmets and hard hats. It's time we move the industry away from a hard hat that only gives you limited head protection from a dropped object, as opposed to a helmet that's designed with Z89 and 12492 in mind. That's clearly designed to do both. And that's what we're advancing, that technology. So respiratory protection, moving on. Respiratory protection is critical today, especially as we deal with the COVID situation, and there's a lot of KN95s. And so I want to be clear, KN95s are not legal for respiratory protection in the workplace. There's an OSHA letter out from April that basically states what I just said in one sentence. They have a full page saying that. So a lot of people are giving their employees KN95s as face covering, and that's fine, I guess. I think what we need to understand is it's important when we restrict the breathing of an individual that we make sure that they can deal with that restriction of oxygen and a restriction of air to their lungs. And it's the law that when we put someone in respiratory protection, that they have medical clearance and they deal with the annual fit test. When I put someone in a KN95, I'm still restricting their air. And are they designed to deal with that? Is their body capable of dealing with that restriction? So keep that in mind. And you are raising the temperature around their face. You're restricting their ability to breathe. So be very careful with these KN95s in the workplace, that you're not using them for respiratory protection. There is a lot of scams going on in the marketplace out there. People trying to sell you something that they say is a KN95. It is a Chinese standard. It is not an American standard, and doesn't follow NIOSH protocols. I would strongly suggest you look at ways to go to the cartridge operated respirators away from the N95s as well, for the following reasons. And these are the KN95 versus the N95. N95s are respirators. They must be under the NIOSH respiratory protocol. KNs are not. KNs are purely, in the United States, just nuisance face protection. I look to people to look for ways you can go to a half face versus and a PAPR versus an N95. And this is the N95s that we see on people. And the problems with N95s is you're spending some money on these things, and your workers are throwing them out 3 or 4 times a day, or maybe 5 times a day. They are getting scarce. N95s are very scarce, and you're seeing unbelievable price increases. So I would ask yourself, if I do need respiratory protection, one, is there a means and a method to get out of wearing any respiratory protection where I can use engineering methods, use some ventilation to take that hazard away from my workers before going to respiratory protection? If I have them in current N95s, is there a way I can move them to half-face respirators, something like this, that I can move them into a P100 cartridge, that's the purple cartridge, that actually filters better than an N95. Some of these cartridges can last up to 30 days. Just in nuisance dust areas, they can last up to 30 days. You're not throwing them out 3, 4, or 5 times a day, so your waste factor goes way down. The breathing, the ability to breathe or take in air, in a lot of cases, is less. Your breathing resistance and your exhalation resistance on a half-face respirator, the one I have in my hand has probably the lowest, is a lot better than a N95 or a KN95. And so you really should look at different means and methods. The PAPR is a powered air purifying respirator. Those cartridges can last up to 30 days. Now you're pushing air to the worker. And another advantage of the powered air purifying respirator is you don't need to fit test annually anymore. You still have to go through the medical review, but you no longer need to fit test the worker if they're wearing the loose fitting style like I have, like in the pictures of the PAPR. So you have to think about a PAPR as another way to save money and be more productive, especially in the summer months. A PAPR is pushing cool air across the worker's face, so it may help us with heat stress as well. So there's a lot of really cool technologies out there when we talk about respiratory protection, when we look at COVID, or we look at respiratory protection in the workplace. How do we protect our workers truly and keep them safe, where they're not overheating, where they're not restricting the air to their body, so they can maintain their posture, they can maintain their ability to be alert on the job site and not get hurt from it. Hand protection is another area that we're dealing with COVID, especially with the single-use gloves. Whether it's a nitrile glove or it's a cut-resistant glove, we're going to cover both today. So there is a massive PPE shortage going on in the marketplace. As I said, with the N95s and KN95s, there's a big shortage going on in the marketplace to getting those because of everybody utilizing gloves, utilizing face coverings and never had to wear them before. So prices are going high. The same is true on people wearing single-use nitrile gloves like I have in my hand. These nitrile gloves have seen the most increase I have seen in my 27 years in the safety business. We have seen base cost of nitrile itself, the liquid nitrile when we make gloves, to be in that 30 to 50% range. All the raw materials, the packaging, the downstream costs, the shipping, this is going up super high. If you have your workers in nitrile gloves, I will tell you, make sure you get with your distributors now and order and get them in. There is going to be a shortage for the next 6 to 18 months in the marketplace. We have things called MCOs. Those are move control orders, where they make most of these nitrile gloves is Malaysia and China. And Malaysia and China are not allowing people who work outside the country to come into the country to work in the glove market. So the reduction of labor is about 60%. The cost of the labor is going up. If someone who lives in Malaysia and is Malaysian doesn't want to go to work because of COVID, they still get paid. So the cost of making that glove goes sky high. And so we're not able to up production. And also the increased cost of nitrile itself is causing a massive amount of price increases. So if you do use nitrile gloves as part of your PPE, please look for alternatives out there or stock up. It's going to be a while, and please realize that your costs are going to go probably double in the next 6 months for just a regular nitrile glove. And that's just because everyone's wearing them now, and there's an ability from these manufacturers of the base product of nitrile to squeeze everybody, and that's the reality of it. So COVID situations, MCO in the next slide, increases of 47%. To date, we've had 47%. The chemicals in the processing are going up to 60%. Packaging costs increase. So these are all adding to it. So what can we do? We can start looking at different types of gloves. There's gloves like TPE. It's a thermoplastic that you can use, or vinyl gloves that we can use if we determine that nitrile is too costly or hard to get. And so this is what one alternative. This is a nitrile glove, but it has the ability to be washed. It has the ability to take on and take off. It even has a higher abrasion level on the glove. That's one way we can to get more use out of our gloves. A lot of times people buy a thin and cheap nitrile glove, and then when they take it on, take it off, it rips. Well, this glove has a thicker mils level on it, so it can be taken on and taken off, and has cotton flocking on the inside, so the glove doesn't turn inside out. So I can use hand sanitizer on it. It will not degrade the glove, and I can reuse the glove multiple times before I have to replace it. That's one way. Another way is using that TPE I said before. It's lightweight. Looks a lot like the food service gloves you see in a Chipotle or a Wawa. It is not, and so it does have some pretty great chemical resistance capabilities. It has a high abrasion level. As you can see, it has a level 3 abrasion resistance, which is screaming high. So it can deal with durability issues. So let's look for ways in our PPE to maybe move away from nitrile because of supply chain. Half the cost of nitrile right now, the TPE is. Other hand protection things that we want to be aware of when we talk about cut resistance. I want a couple things on PPE be aware of here. On cut resistance, there's a lot of different cut resistant values. And the big thing I like to talk to people about is when you look and you say, hey, George, I'm having cuts in my workplace. What do I do? And the knee-jerk reaction is to go to the highest cut level. Under ANSI, we have 9 levels of cut resistance. The problem going with the highest level is each time we go higher in cut resistance, we could be reducing the tactility of the worker and their ability to use their hands. So the thicker I get doesn't necessarily mean the better I get. Yes, I may be cut resistant, but the worker cannot do their job. They can't pick up screws, fasteners, tools to do their job. So they tend to take the glove off. And so that's a problem. So look at what the glove can do. Look at the material it's made of. And look for the really 2 values, cut resistance and abrasion resistance, because I can have a high cut value, real thin glove, but now my abrasion level is super low and I'm going to wear it out. And these gloves, the higher values and the more intricate the materials are and they're making, they give you great cut resistance, but you're thrown away quickly because it wears away. So it's important that you study what the workers are doing and understand what the cut exposure is to your workers. So just having a level for having a level's sake of cut resistance may not be the best way. The best way should be is looking at the true hazard to your workers and understanding those cut levels. An example here is a cut level 4 can go from a level of 1,500 grams of cutting ability through the material to 2,200. So you could have a different price between the cut 4 when you compare your suppliers and you go, well, you're cheaper than this person. It may not be because they're just cheaper. It may be because their cut value is higher than the one you're comparing it against. And that goes back to our theme from the beginning, is read your manufacturer's recommendations, read your test results, read your declarations of conformity, and see what that glove can and cannot do. So what is the real cut level in grams when I'm dealing with it? What is the abrasion level? If I'm paying a lot of money for cut resistant gloves, how long are they going to last? And do I have the right dip on the glove to do the job? There's multiple dips on gloves. You can have urethane, which is real thin dip. That's the black part on that glove. You can have nitrile, which is a little bit thicker and has some gripability. You have a microfoam nitriles that allow water and oils to pass through or pass the dipping material, so you maintain grip. What are you doing? Do your employees need touch screen when they're wearing their hand protection, which is important? As I say here, high cut resistance doesn't matter if it doesn't give you hand protection. In other words, do they have to take the glove off to do something else? Once they take the glove off, they don't have cut resistance. And what material the glove? Fibers. And there's different fibers out there for cut resistance, whether it's Kevlar, Dyneema, and some of the Spectra products and the blends that we're dealing with today to get the high level of cut resistance. So hand protection is critical. Finding the right hand protection is more important. And so I was asked to keep it between 40 and 45 minutes. I think I'm exactly at 38 minutes. I know I probably went a little bit quick. What kind of questions do we have for the group?
So thank you, George. I greatly appreciate your presentation, and I have learned a whole lot. And for those of you on, my name is Debbie Jennings, and I'm with the Chesapeake Region Safety Council, and I direct the traffic services programs and some of the social media and marketing efforts. So questions include, as always, will this presentation be available afterwards? And yes, we will put it on our YouTube channel and links on our social media to that. There do not appear to be any questions coming in at this time. And for those of you on, if you do have questions, you can send them to safety@chesapeakesc.org, and we will get them to George so that he can respond directly. Thank you, George, for your time. This was really informational. I learned a lot. I'm going to go back and watch it again because I didn't realize how much of it is just applicable to my regular life and things I'm doing, and the issues with the marketplace right now. So it's really valuable information for all of us, and we'll promote it that way.
Thank you very much.
Have a great day, and we'll see you soon.
Thank you.
Thank you, George.